Let's go to LeetCode 1381. Design a stack with increment operation. So this question give us let us to design a stack, and this stack should support push, put, pop in the increment operations. So for the push, um, that is added item X to the top of the stack. It also gives us a max size. That means we cannot push if there are already max size items in the stack, then we are not able to push. We just return. Do not push that into a data structure. And the pop will return the top of the stack. If the stack is empty, just return -1. And the increment k value will increment the bottom k elements of the stack by value. If there are less than k elements in the stack, increment all of the elements in the stack. So it let us to design a stack, right? So this will depend on whether the question allow you to use direct stack directly. If you allow us to use the stack, we can possibly put a stack field, right? If that's not allowed to use stack, we can just use the integer array. So let's use the integer array and also use the index to maintain the position of the item array. And yeah, we are going to have an index. So we know there is a max size, right? So we can put this variable outside so that we know if when we push the index is equals to max size -1, then we just return. So we'll have array equals new int max size, and the index equals -1, and this dot max size equals max size. So for the push, what we do is we will say if index equals max size -1, we just return. Otherwise, we just have array to the index, right, equals X. So for the pop, it will be similar. And if we can use this kind of array, right? And say if this kind of index equals -1, then we return -1, right? Otherwise, we just return array index in minus, right? That is we get this item, then move the index, right? For the increment, here is the thing is that we are trying to from the bottom to k, right? To add the items to be value, right? So what we do is that for int I equals to 0, I smaller than k, let's say let's name k and the index plus one, right? Because it's possible we don't have that many items. We don't have one key items. Then we'll have I plus plus. Then we'll have array I plus equal to value, right? Doing like this, there is some kind of problem. It's actually the increment. You see, increment is actually an OK operation, right? So actually we can do it better um, for the increment because there is some kind of for loop here. This for every increment, it will do a for loop. Actually, we know there is something called diff array, right? We don't need to, if we want to increment a number from um, index I to j, what we do is that we add to index I plus value and index j plus 1 to be minus value, right? For stack, that is the same thing, right? That is we we are increase to this index, right? So what we do is that we add this value at the index and should be also mean k minus 1 to index, right? And if we want to minus the value, that's at the actually at the index minus 1, right? For this question, we can ignore this because this does not affect our calculations. So we just have a diff array which at index k minus 1 or index, right? The mean of this to be add value. So we can use a diff array here. Int diff. We'll say diff array equals new int max size. So here for pop, let's write increment first, right? So our increment, let's say int and id equals max dot mean k minus 1 and index. So we'll have mm, so that means that if this kind of NID, right, is greater than minus 1, right, means there is items in the stack. Then we'll have diff and ID um, that's equal to value, right? And when we pop, so we'll see this will not affect the push, but it will affect the pop. So the pop will be, let's say, well, I change this something like int value equals array index plus diff index, right? And we'll say we are going to when we calculate um, the we use out this kind of diff, right? Our pointer will move to the next, right? Our pointer will be moved to this, right? Um, so when we use out this, we can set that we'll say if uh, idx is greater than 0, we have diff idx minus 1 equals diff idx, right? And then we also stated that if IDX equals to 0 after usage, and we just return value. This is not equal because it may have a value, right? The remaining values for other operations should plus equal to. Doing like this, the increment will be O1 operation instead of OK operation. And yeah, we can also change this to Python code. So we are going to have in self have the property max size of max size equals max size. And we're going to have self dot array equals 0 multiplied by max size. And we're going to have self dot diff array equals 0 multiplied by max size. And we're going to have self dot index equals -1 initial index. So for push, let's say if self dot index equals self dot max size -1, right? Means we reach the capacity. We just return. Otherwise, we'll have self dot index should pass equal to 1, and we'll have self dot array self dot index equals x. So this will be push. And for increment, right? So we'll say the end index equals mean a minus 1 and self dot index. So we'll say if end index is greater than -1, right? Means this stack is not empty. So we'll have a self dot diff array and index should pass equal to value. So here we do this, right? It is just O1 operation instead of OK operation. So for pop, that is if self dot index equals -1, we return -1. Means this is empty, and we'll have way value equals self dot array self dot index plus self dot diff self dot index. So we'll say if self dot index is greater than 0, we need to pass the diff array to the index -1. So we'll say if self diff self dot index -1 the pass equal to, right? Because it may have remaining values in some other operations. Self dot diff self dot index. And because our current index value after pop, the value is used, right? So array, we can clear the um, array item as well, but since that it will not affect. But for diff array, because we need the cumulative values, so diff array, we should definitely clean the self-index diff. For self-array, it doesn't matter we clear it or not. So we'll say uh, self dot if self dot index equals 0 because that hasn't done exist anymore, right? So we'll have self dot index. We are going to decrease by one and return value.